Hey guys, today we are going to discuss this problem. So we are going to use the example here. So it will give us four numbers. So A, B, C, D, right? Four numbers. And before we continue, we are going to introduce the non-degenerated triangle, right? What is non-degenerate triangle? So that means, um, let's say the triangle has three sides. The names of the three sides are A and B and C, right? They must satisfy these three conditions. If all of these three conditions are satisfied, we call it a non-degenerated triangle. So it basically means that if we have three sides with the length of A, B, C, if two two of the sides are too small, let's say uh, A is short as this one and B is short as this one, then C can never be the third side for these two sides, right? So we have to make all these three statements true in order to have a triangle, right? So with that being said, um, the problem here is we are going to have four numbers A, B, C, and D, right? And we are going to find out how many triangles we can get from these four numbers by choosing one side from A to B and choosing one side from B to C and choosing the last side from C to D, right? In this case, we have 1, 2, 3, 4, so that we can choose the first side from 1 and the second side from 2 and the third side from 3. But in this case, 1 plus 2 is equal to 3. So this can never be a triangle, right? So we replace the second side with a 3. So in this case, all of those conditions are satisfied, right? So this is a good three-sided triangle, right? Um, let's see if we can find any more triangles. We can use 2 as the first side, and 2, another 2, second side, and 3 the third side, but not the valid triangle, right? And let's see if we can have more here. This is another one, right? And any more? 2, 3, 4, right? 2, 3, 4 is okay. Cool. So anything else? No, I can't find anything else. So four triangles we can find. So we output 4 here. So how can we solve this problem? Um, the range of the problem is, let's take a look. So it's 5 multiplied by 10 to the power of 5. So it's a quite big number, right? So let's first we don't consider that a restriction. So let's say we don't concern about the time complexity. The most naive solution is to we iterate through all of the possibilities of first edge. We call it x, right? We iterate from 1 to a and iterate all of the possibilities of the second side from from A to B. And for the last side, actually, sorry about that. This one should be A to B, right? The first side must be A to B, and the second side is from B to C, and the third side is from C to D. So if we check each of the three conditions, if all of them are met, then we can increase the answer by 1, right? If we iterate all those possibilities, we can get the final answer. So the time complexity of this solution is Ln squared, right? That is not good enough for our problem. So if we dig a little deeper, we can find out that if we have the first two sides, if we iterate through all of the possibilities of the first two sides, we can just calculate the range of the third side, right? Uh, because let's see, be, uh, we can easily get that x is smaller than y because we have A, B, C, D. X is from A, B, Y from B, C, Z from C, D, right? So obviously X is smaller or equal to Y. And Z is smaller or equal to, Y is smaller or equal to Z, right? So in this case, A plus B is not necessary, X plus Y is not necessarily bigger than Z, but X plus Z is surely bigger than Y, right? So we don't need to consider this condition anymore. And Y plus Z is bigger than X, obviously, right? Because Z alone is bigger than X. So we don't need to consider this condition anymore. All we need to consider is this condition. So how do we make sure that X plus Y is bigger than Z, right? So in this case, we iterate all of those X plus X and Y possibilities so that we only need to find out how many Z we can have for this pair of X and Y. And we can add that into the answer, right? For example, if we are checking if X equals to 1, let's say X equal to 2, and Y equal to 2, then what can we choose for Z? We must choose a Z that is smaller than 4, right? And we have the initial range of Z, which is C to D. Then we can just calculate intersection of C to D and 0 to 5, right? In this case, C equals to 3 and D equals to 4, so that all we can get is 3, right? If we have two twos, then the third edge must be 3, right? That's how we reduce the time complexity from n squared to n, actually reduce from n cubical to n squared, right? So that's our first way of optimization, but still, it's not good enough, right? How do we make it even faster? So the thing we did here is we iterate all the possibilities of x and y, right? In fact, we can only iterate through the possibility of x plus y, right? So what does that mean? So instead of iterate both x and y, we're going to iterate I from 1 to, actually, let's draw it again here. We're going to iterate I from A plus B to B plus C. And I here means the sum of x and y, right? Um, for this solution, I is the sum of x and y. So we iterate all of those possibilities of I. It starts from a plus b because the minimal value of x is a and the minimal value of y is b. And the maximal value of x is b and the maximal value of y is c. So we iterate from a plus b to b plus c, right? And we are going to calculate how many possibilities we have for x and y that can have a sum of I, right? So let's say we already know that I equals to 4. Then we can know in how many cases where x plus y equals to 4, right? How do we calculate that? So we are going to find out first. We are going to have the range of x, right, which is b a to b. In this case is 1 to 2, right? And I we already have is 4, so that we have another restrictions for x, which is we need to make sure that the y in this case is valid, right? So because 4 is I here, and I equals to x plus y, so 4 minus y, actually 4 minus x should equal to y, and which should be small or equal than 3, and bigger or equal than 2, because this is the restriction of y, right? Y is between b and c, and this is c and this is b. So we can have another 2 restrictions on x. So to convert it, we can have x should be bigger than, we move this guy to this side and move this guy to this side, so we can get x is bigger or equal to 1, and we move x to this side and move 2 to this side, and x should be less or equal than 2, right? So we can get another restrictions on x, right? Which is the same as the previous restriction of A and B. So we have 2 possibilities here for x, right? So if we have I equals to 4, we have 2 possibilities for x, which means we also have 2 possibilities for y. But in this case, we are going to multiply it by the possibilities of z, right? So what is the possibilities of z here? So because x plus y already equals to 4, so that z must smaller than 4, right? That is the one more constrictions we have on z. So currently we have z is bigger than 3 and smaller than 4. So uh, so in this case, these must be smaller than 4. But the CD's constriction tells us z can be 3 or 4. So we eliminate 4 for this condition's sake. And we only get 3 as this value. So z have one possibilities. So we multiply the number of possibilities of x, multiply by a number of possibilities of z, which is 1. So the total possibilities of I equals to 4 is 2, right? And we are going to iterate all the possibilities of I and add the final possibilities to the answer, right? So let's take a look at the code. So we are going to open the web page and look at the code. So here we are going to have a small function here. So this function is to calculate the intersection of two range. That this is a small function, right? What it does is that we have x um, and x0 and y0, and we have x1 and y1, right? Basically, we have two ranges, two conditions, and we are going to get the intersection of these two sets, which is this part, right? So we must make sure the number in the intersection is both in the first section and the second section, right? And the way we calculate is really simple, which is to get the maximal value of the mean of the minimal value of these two range, and get the smaller value of the two end point, right? We get the maximum value of the starting point and get the smaller value of the ending point and use it as a final range, right? If the range is smaller than 0, that means it is 0, right? In that case, if we have a two ranges like this, then these two sections don't have a intersection, so we return 0, right? So that's how we calculate the intersection of two range. And here is the main function. First, we're going to read the ABCD. Then we're going to keep the final answer in this variable. And then we're going to iterate through all of those possibilities of x plus y, right? I started from 2 here. It must not be the most efficient option, but it's viable. In the worst case, I just iterate through some possibilities that never gonna happen, right? And when we get the sum of x and y, we're going to calculate the number of possibilities of x and y, right? In this case, the number of possibilities of x equals to the number of possibilities of y, right? So we just need to calculate the intersection of AB and this two number, right? And this is where we calculate the number of possibilities for Z. And also we are going to use intersection function. And then we are going to multiply them together and add it into the final answer. And we are going to iterate through all of those x plus y and output the final answer. So I guess that's it. Thank you for watching.